everybody. Welcome to Cloud Cover. My name is Chris Risner. Today I'm joined by Haishi.
Hello.
Hello, Haishi. It's good to be back with you. Today our special guest is Jeff Mendoza. Jeff, would you like to introduce yourself?
Sure, yeah. My name is Jeff Mendoza. I'm a software engineer at Microsoft Open Technologies. And lately I've been working on Docker.
And that's what you're here to talk about today, right?
Yep.
Fantastic. Before we get into the main presentation, we're going to go over a little bit of news. Now, this episode's probably going to go out a little late from now due to the holidays, so some of this stuff's going to be old, but you may not have seen it by the time this comes out, so we'll just go through what's new today. So first off is the public preview for the premium storage for virtual machines. So you're going to get up to 32 terabytes of storage per virtual machine, with greater than 50,000 IOPS per VM, less than 1 millisecond read latency. So a really great option when you need premium and great access to storage. So we'll just keep going. Remote app general availability. This was actually mentioned in the last episode, but I think it wasn't official at that point, but now it's officially GA'd. So a really great way to access your both kind of on-premise business apps as well as apps in the cloud, so you can access on-premise data from any devices using the remote desktop application. SQL database, SQL 2014 features and compatibility, so near complete SQL Server 2014 compatibility, some really great new features, some really great performance improvements. Media services, general availability of the live media streaming. As far as Azure Search goes, which we've had on the show before, you now have some portal management. So previously it was all done via the API, the REST APIs. So now you have portal management as well as multi-language support for search. Document DB, you can now bulk add documents as well as do syntax highlighting for when you're doing your querying and editing. Good stuff. And then as far as disaster recovery, we got GA of disaster recovery for branch offices and SMB customers. And then also GA of application proxy and password writeback for Active Directory. And I think that's going to be it for news today. So we're going to go ahead and switch over to our main presentation. And we're back. All right, Jeff, let's hear what you have to say about Docker.
Sure, yeah. So I wanted to go over first a quick overview of what Docker is, and then talk a little bit about how you can use it as a developer and then use it on the cloud.
That would be great, because I know of Docker as being a whale with some containers on top, which I think would be really cool to see, but yeah. I think it's probably more than just that.
Sure. Yeah, so here I have just Docker's website on what is Docker. And if you scroll down, the first thing you see here is like two paragraphs. Why do developers like it, and why do sysadmins like it? And that's because Docker often kind of fits into this DevOps role. So they don't say it explicitly. DevOps is kind of a buzzword these days, but it's really good for both. It's good for developers and it's good for sysadmins. I'm a developer myself, so I'm going to try to hit that angle for you. But there's a lot of benefits for sysadmins: density, ease of use, and those types of things. So this kind of diagram here is a good, very high-level overview of actually what containers are and what Docker does for you. Sometimes, people come to Docker thinking it's a lightweight virtual machine, and that's an okay way to think about it at first. Maybe you'll think about it differently later. Containers are a lot of different things for everybody. But if you look at it compared to virtual machines, you can kind of see the differences here. With virtual machines, you're running a full stack on top of the hypervisor for each app you want to run. Typically, you run one app on each VM to keep them isolated and for dependencies.
And that's literally what IaaS is for Azure. It's virtual machines, just like that.
Yep. But you're running an entire guest operating system for each virtual machine that you want to run. So what Docker does and what containers do is they run your application inside of basically a steel box, and that gives you the same sort of isolation that you would have with a virtual machine. You can have all of your dependencies. You don't care about anybody else's dependencies. You cannot worry about stepping on the toes of any other container running, but you're running only your application. You're not running an entire operating system. So it's your application plus any dependencies. Usually just a single process is running. You're not running init. You're not booting up a lot of services. And all of those run on top of the host OS. Right now, that's the Linux kernel only. With this diagram, the Docker engine here is maybe a little bit misleading. It usually actually sits to the side. You talk to the Docker engine to start a container, stop a container. It configures the kernel and the file system, the networking for you. But once that container's running, it's running directly on top of the kernel. All of the containers share the kernel.
So one way of looking at this is you build an application and you use some sort of an SDK provided by Docker to basically talk to Docker as opposed to the actual operating system itself, and that way you can basically just redeploy and it's always going to function the same?
That's exactly what we're going to do.
Great, awesome.
Yeah. Okay, and so when you're running the Docker containers, it's just like running your application on a machine, and the performance and density you get is like running just applications on a machine. You're not running full VMs. So now I'd like to dive in and see what we can do with Docker.
Great.
Okay. So I'm going to pretend that I'm a Python web app developer. And I'm working on a web app, and I want to deploy it to the cloud. But of course, I have lots of things that I do. I need to develop it. I need to test it. And then I need to deploy it to maybe somebody else or maybe myself to my own cloud machine. So here I have a web app. And if we look at it here, main directory here is web app. And in here I have my Python file. It's app.py. I have the code up here. And it's a really simple web app. I'm just getting started. So it basically does hello world. And it uses this Flask framework. So to run it on my computer, I would run Python app.py. Oh, and I'm not in the right directory. And it's going to run. I'll open up another terminal and just make sure that it's running. And hello world, it's working. So great. I wrote my web app, it's running on my computer, now I need to deploy it.
One quick question. Now, I'm not really a Python developer, so when you import that Flask framework, is that something you or something you have to install side by side?
Yeah, so that's a Python package.
Okay.
So you have to install that, you have to get it somewhere.
Right.
And I'm going to show you right here that I have some packages installed, and I have Flask 0.10.1 installed. Also, I'm running Python version 2.7.9.
Okay.
So this is my system. Now, if I give this app to somebody else and I say, hey, run this on your Mac, and you have a different version of Python, a different version of Flask, a different version of all these other Python packages, which are dependencies, it might behave differently.
Sure.
I mean, that's not the intention of the people who wrote these packages. They want it to work everywhere, but things happen.
Well, that would be like going from something that's written in .NET, one version of .NET to another version of .NET. It might not just really function
Exactly.
the same.
Yeah, and this is the problem that Docker solves for developers.
Yeah, and that's one of the key friction point between the devs and ops. When devs release an application, there's also implications what the environment should look like, but that's not clearly communicated with ops, and they build a different system.
Yep.
Yeah.
So to get started with Docker on my application, what I'm going to write is a Docker file. And a Docker file is how you just build a Docker image. So I've got my Docker file right here. It's pretty small. It's not too hard to get started with Docker if you're an app developer. So the first line here is from Ubuntu 12.04. And that's going to be the base of my image. So I don't have to start from scratch. Canonical puts out base Ubuntu images that you can use to get started. And this really lets me get started with Python real easily, because I can use the Ubuntu package manager to basically install Python and all the dependencies that I need. The next thing you do is you add my code into the container. And then run a pip install. This installs those Python packages that were not part of the Ubuntu packages. And then the last thing here is command Python app.py. And that tells Docker what command to run when I want to run this image.
One quick question. So when you specify the Ubuntu 12.04, that's not really specifying, hey, use this operating system, right? Because you're not setting up the operating system for the containers. Is that
Well,
right?
it is, but you're not. When you run the container, you don't run everything.
Right.
So you don't start up Ubuntu when you run the container, but you are using all of Ubuntu's files to build my container.
I see.
So if I'm using Ubuntu's version of Python, for example,
I see.
that's in 12.04,
Okay.
and it's always going to use that one whenever
Okay.
you build this.
Great.
And I guess one of the significance of this Docker Docker file is that it explicitly capturing what the infrastructure should look like to support my application.
Yes.
It's not implied anymore.
Yep.
You know exactly how to build up from scratch, how to run my application.
Great.
So to get started with Docker, since right now it is only on Linux, I need a Linux machine. And as you can see, I'm running Windows here. So I'm going to take advantage of some of the work that I've been doing in the Docker community and some of the other Azure developers have been doing and use some of the new tools. The first tool I'm going to use is called Machine. So Machine is a new tool from Docker, and its aim is to get you started quickly, especially if you're not already running Linux. So one of the things it can do is it can get you a local VM on your laptop, and it can also get you a machine in the cloud really easily. As you can see here, I actually have two machines already that I set up before this. One running on my local machine, a Hyper-V VM, and the other one, an Azure VM running in the cloud.
Okay.
So the first thing I'm going to do to get started if I were a developer is just kind of run things on my laptop. So I'm going to use my Hyper-V VM. The next thing I have to do is set a couple of environment variables to tell Docker which VM to use. Now, I will say that Machine and a lot of the Docker features I'm using are currently under development in the community. So there are some things not done yet. For example, we plan to have a better integration between Machine and Docker, so you don't have to set these types of environment variables.
But say for this local virtual machine, do you provision the machine using the machine command or just connect to the machine?
You do provision it. And I'm not showing it right now because it would take a while to run.
Okay.
But the machine create command is what you would use. Right now we have the Azure support, and you can set all your Azure variables here. Hyper-V support to set your Hyper-V variables here.
Okay. So you can use the same command line not only to provision a local machine, but also an Azure virtual machine that support Docker.
Absolutely, yeah. And so I set my environment variable, and I'm going to make sure my Docker is working with my Hyper-V VM, and it's talking properly. The other thing I'm running here is the Docker client for Windows, which is another thing that hasn't been released yet as part of a Docker binary, but it's part of the Docker open source project currently. It's in the upstream.
So anybody can go out there and grab that right now?
Yeah, you'd have to go build it yourself because
Right.
Docker we haven't had an official release that you can just download and install. So right now the code is being worked on in the open source community.
Great.
Yeah, so my Docker's working, and I want to get back to building my web app. So I'm going to run docker build. I'm going to give it a tag my web app and build the current directory. So it's basically running my Docker file now. In each line, it's going to save as a new container. And that helps you out when, in the future, if I just change something further down in the Docker file, like I add some new code, it caches all the previous lines, so I don't have to rebuild some of the time-consuming steps, like this apt-get install, for example. So while this is running, looks like we're apt-get installing Python and all of the dependencies. I had previously pulled down the Ubuntu image, so that pull over the network was pretty quick. But normally you would have to pull this down if it's not on your local Docker host. And I should say that this from Ubuntu is pointing to the Docker registry. So Docker runs the Docker Hub, which includes the registry, and this is where people can publish images publicly, and that's where Canonical publishes their base Ubuntu image publicly, which everybody can use if they wish. All right, so my container was successfully built. If I do Docker images, sorry, I should say my image was successfully built, I can see my web app is built. So now to run my web app in my Docker host, my VM running my laptop, I just do a Docker run, my web app. I want to give it a couple options. I want it to forward ports, and I also want it to run in the background. Docker PS lets me see what's running, and I can see that my web app is running. It's running that command python at py was the default command, and it's forwarding this port to the container. So now I can do a curl on that. I need to see what the IP was of my machine. I can do machine IP HV. Will tell me my Hyper-V machine's IP, and curl this IP. and this port. I can see that that's running.
Great.
So I've successfully created a Docker file for my web app that I'm developing. I built the image. I'm running it in my local Docker host, and everything looks good. So it's all of its dependencies are built into the image, and I can now share this with anybody, and they should be able to run it and get the exact same behavior anywhere that Docker containers can run.
Yeah. So if this dev test or even for production, they can just take the container and run
Yep.
in a different environment.
Yep.
It's all consistent.
Yeah. Now, if I wanted to use my Azure virtual machine, let's say I want to get this running in the cloud so that people can start hitting my web app, I would do all the exact same steps. If I look at the machines that I have running up in Docker machine, I should see my Azure machine. Yep, here it is, the one I already created here. I could reset my Docker host and then do the same steps, Docker build, and then Docker run. I don't want to do that right now because I want to show you, instead of building, what you would do if you wanted to now push an image to the Docker registry. So right now, as it is, I can take this code from anywhere, run a Docker build, which will build the image on that machine. But if you want to share images without having to share the code and the Docker file, the Docker registry is there for you. So the first thing I would do if I wanted to use the registry was put my code on either GitHub or Bitbucket. Those are supported by the Docker registry. And
this is the web app code itself.
this is the web app code. Yeah, I've got my web app here with my app py. Oops. And then my Docker file here. And it's ready to go. Anybody could download it and build it. But the next thing I would do is I would go over to the Docker registry and then create an entry for my web app and link it to my GitHub repository. And then what the Docker registry and Docker Hub is going to do then is build it for me. They give you free build resources for open source projects. It takes the code and the Docker file, builds the image, and makes it available over the registry. So this user is training, the name of the web app is web app. So now this image can be pulled directly from the Docker registry without having to build it from the code.
So when does Docker rebuild your application? Every time you push to your repository?
Every time you push to GitHub, yeah. And you can have tags other than latest. Right now, I believe latest is the only one here for when you make releases of your code.
So now, could you go into a Docker file, like before we were saying from Ubuntu 12 or 12.4 or whatever, you could change that to say from web app, and it'll basically start from that image in the Docker registry?
Yeah, and people do that a lot. They build on top of other people's stuff that way.
Makes sense.
Yeah. So I'm going to set my Docker host to my Azure VM. And let's make sure it's working. Oops. Yeah, it looks like it's up. And I'm going to do Docker pull training web app. And here's where you could say something other than latest if you wanted to pull a different version. This will take a little while. And so now instead of putting my code and doing a Docker build, I'm pulling that down from the registry. I already had Ubuntu pulled on this machine, so it should only be pulling the slices. That's another thing I want to mention is when you write your Docker file from Ubuntu, if you have different images on the same machine that use the same base, that base will not be downloaded more than once. It actually builds your Docker files, your Docker containers as layers, so that saves bandwidth and disk space.
So I think earlier what you said and kind of what you're talking about now is like when it runs and actually builds this file, it actually makes a container for each line, so you're caching that.
Yeah.
If you have a separate Docker file that, let's say, uses the same 3 lines, is it going to pull from that cache, or is it going to rebuild those?
That's a good question. I don't think so.
Okay.
I think it kind of clears that out as it builds, but I'm not sure on that one.
Okay.
So I'm going to do a Docker run again. Actually, I'm going to do images. And instead of it being called my web app, which was the tag that I gave on my local Hyper-V VM, on my Azure VM, it's called training web app. Run it in the same way. Actually, this time I want to give it a port 5000 directly. And then do -d for running in the background. Training web app. And it runs. Again, Docker PS is going to see it running using port 5000. I messed up. I didn't open that port on my Azure VM before I started this. So I will show you something else, actually. I'll show you another machine command. SSH, when you create a machine with machine, it saves all of your credentials and things. So you can just SSH like this. Name of my machine was Azure. Here we go. And I can do a curl here. And see that my web app is running. Yeah, so that was just a quick overview on how to get started with Docker, how to take if I'm an app developer, how to Dockerize my app and the benefits that it gives me, and then how to use some of the tools that we're working on for Windows and for everybody else to use machine to create local VMs on Windows, to create on any machine, create VMs in the cloud, and then use Docker to then run those containers.
Great. And so from Microsoft side, what we're really contributing to is some of that tooling to basically run all of the stuff from a Windows box as opposed to always have to be on Linux.
Yep. So the Docker client used to not work on Windows. That, like I said, that's been contributed and accepted upstream. It'll be in the release of Docker probably 1.5. The machine is a separate project. It's undergoing pre-releases right now. You can get a 0.3 release of machine. It has Azure merged. Hyper-V is currently a pull request, and it'll be merged soon. And then we should look at a machine 1.0 release around the same time that Docker 1.5 comes out.
Great. And now you've been using Ubuntu. Will this run on other flavors of Linux?
Yes. So now I was using Ubuntu here as a base for my image.
Okay.
So if you go back, let's go back to the Docker registry. I actually kind of wanted to point one thing out, is that there are things called official repositories here. And like I said, Ubuntu is one of them. CentOS is another one. Even there are many unofficial base images of Linux that you like. You don't even have to use a distro. Like if you knew how to build Python and put it all into an image yourself, you could just do that. Like if you don't need all the rest of the distro to be a part of your image, you don't have to use it. Now it's much easier to.
Okay.
So that's the image part. Now the host part is the other thing. Docker runs on most Linux distributions, but it really doesn't matter what it is. Like on my local machine, the Docker image I was booting up was called boot to Docker, which is an absolutely tiny Linux distribution that has almost nothing in it. For the Azure machine, I was using Ubuntu, but we also support CoreOS for our machine code. That said, if you ran Docker on SUSE or CentOS, it would be just fine as well.
Great. So where can people go for more information about using Docker with Azure?
Sure. So if you wanted to check out the machine source code, it's, sorry, not Azure, Docker machine. Yeah, where you could go download all the latest machine code. Like I said, the Docker, the Windows binary itself has already been merged, so if you went to Docker, you could see that there.
And you said the Hyper-V currently is a separate pull request for this?
Yep, it's, let's see. Here it is today. Hopefully it'll be merged soon.
Okay.
Yep.
Cool.
Great. This is really very amazing stuff. It's
Thanks.
fun to see the containerization stuff and actually
Yep.
understand what it is besides just a whale. That's really great. Anything else you want to tell viewers before we close out?
Well, I guess we'd like to hear feedback, like if you like machine or if you have any problems with it, put issues on GitHub, and I'll be looking for those.
So obviously the machine repository, that's where those issues should go. Anywhere else they should provide feedback?
Docker for Docker, anything to do with Windows or just Docker in general that we could make better.
Okay, great. Well, thank you so much for coming and showing us this, Jeff. Appreciate
Thanks.
it.
Thank you.
Everybody out there, thanks for watching. Oh, do you have a Twitter handle in case people want to get a hold of you?
Jeff Mendoza.
Jeff Mendoza. Can you give us one of these and we'll actually edit it in there? Perfect. All right. Thanks for watching, everybody. As always, follow us at Cloud Cover Show, and we will see you next time.